Okay, so we've already learned how to name various compounds. So if we're talking about covalently bonded compounds or molecular compounds, what do we use to name them? Do you guys remember? Covalently bonded. Okay, now don't all you guys yell at me at once.
Would it be the Greek prefixes?
Greek prefixes, that's right. So we're going to be using those Greek prefixes. Okay, and we know that that's only when they're all nonmetals. So we're going to use those Greek prefixes when they're all nonmetals, and then also when they don't have, let's say, hydrogen and AQ next to them, because we learned how to do acids as well, right? So if we recall, H2SO4, AQ, we know that this is going to be an acid. So this is not going to be a covalently bonded compound. It's actually going to act like an ion, okay? Because of the AQ and because of the hydrogen that's in front, the H2. Now, if I had H2SO4 and it was a gas, then this is covalently bonded. Okay, so then we would go ahead and name this using those Greek prefixes. So what would I name this compound here? Okay, this is an interactive class. It's just like regular class. So interact. Okay, I guess we're going to have to volunteer somebody, huh? Ashley, are you there?
Yeah, I'm just trying to go through my notes really quick.
Okay.
Would it be hydrogen tetrasulfate?
Nope. Now you're going to use the Greek prefixes for each of the different elements. So how many hydrogens do we have?
It would be dihydrogen
Dihydrogen.
and then tetrasulfate.
No, because here it's not acting as a polyatomic ion. It's not an ion in this case. Because it's a gas, it's all going to be the Greek prefixes. So this would be dihydrogen, like you said.
And then sulfur
Hmm.
tetraoxide.
That's right. Okay. So when you've already established that they're all covalently bonded, if they have a gas or a solid, then you know that that's going to be, and they're all nonmetals, then that's going to be all covalently bonded. Then you're going to use the Greek prefixes. When it's like this, it has the hydrogen and the AQ. We know that we named this guy sulfuric acid. And we'll do a recap of that in a minute. Okay, so because it has those hydrogens in front and it has that AQ, it's going to be sulfuric acid. Does that make sense? Because of it being in an aqueous solution, being boiled to an aqueous solution, it causes uh, um, a reaction to cause the hydrogen to act as an ion. And that's part of the reason why, if we look at our periodic table, let me pull it up. Can you guys see my periodic table? Part of it. So we'll notice that hydrogen is here and it's located with the group 1 metals. That's because when it's in an aqueous environment, hydrogen acts like an ion. So it's going to be able to get rid of the electron that it does have. And so it becomes H plus. Okay. And that's the reason why it's located here rather than all the way over here with all of the other non-metals. And so it has like a dual identity, right? So in aqueous solutions, it's going to act like an ion, but non-aqueous solutions, such as gases, solids, it's going to act like a non-metal. Okay? Let's move forward. Okay, so just to remind you of those Greek prefixes, we've gone over them several times. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Then we talked about 11 undeca, 12 dodeca, and 13 trideca. Okay, so do me a favor. And let's go ahead and name these, or write the chemical formula for the first two, and then the chemical name for the last. I'll let you guys give you a minute or two to do that.
For the first one, would it be N2 and S5 and then N2 and then O5?
Okay, so that very first one, first
Yeah.
chemical is going to be N2S5. Then the next chemical is going to be, you said N2
N2 and then O5.
O5. That's correct.
Okay.
Okay, Maritza, can you give me the names of the last two?
Um, Treta, iodine,
Tetra, iodine,
mm-hmm. And Nona, oxide.
oxide.
Yeah.
Right?
Mm-hmm.
Known oxide. So remember with the oxygen, how it doesn't like A's or O's
Yeah.
next to it.
Mm-hmm.
And then the next one,
Phosphorus, well, monophosphorus, or is just phosphorus?
phosphorus. Yep,
Okay.
just phosphorus.
And pentafluoride.
Pentafluoride. So we'll remember that when we talked about it with the mono only goes to the one that's the last element, right? So if you only have one of the last element, you'll use mono. And then if your element is in the front or in the beginning or in the middle, then we just use just the name of that element. So like phosphorus pentafluoride. Okay?
Yeah.
Okay, so we've talked about ions as well. So you guys know what a cation and an anion are at this point. We know that a cation is positive. Cat, meow, positive, okay, and anions are negative, right? And so when we're talking about covalent bonds, we know that we're going to be ionic bonds. We're going to be putting together a cation and an anion, and they have to balance each other out. Okay, so what do I mean by that? Oh, there's a question. So Rosa, you can't hear anything? One second. Okay, give me 1 second while I help Rosa out with her audio. Okay. Can you hear now? Okay. Okay. So we know that we need to balance out those positive and those negative charges. So for instance, if we have magnesium and fluoride. So what ion does magnesium form when it forms an ion? What will be the charge on the magnesium? Is it a cation? Is it an anion?
An anion?
Are you sure? An anion is what charge?
Negative?
Negative. So you're telling me magnesium is negative?
It's gonna be positive.
Okay, it's going to be positive. Why?
Oh, because you're gonna be subtracting two electrons.
That's right. We're going to be subtracting 2 electrons. And how did we determine that we subtracted electrons?
Because he wants to be a gas, and to be a gas is you're gonna be subtracting two electrons to go to neon.
Yes, so it wants to be like the noble gases, right? Everybody wants to be like the noble gases. So we're going to be going to neon, right? So then we'd have to lose 1, 2 electrons. So we know that magnesium is going to be a 2 plus charge. What about fluorine?
It's gonna be a negative charge.
Okay, it's going to be a negative. Now, does 2 minus 1 equal 0?
No.
No. Okay, so then how many fluorines will I need?
2.
I'm going to need 2 of them. So then my chemical compound for this is going to be MgF2. Because we know that now we have 2 minus 1 minus 1, that does equal 0. So we know that anytime that we're working with a ionic bonded compound, they have to always add up to 0. Okay? And you'll notice that we didn't put the charge on it because it adds up completely to 0. Okay? Okay. So this here just basically showing you that all of the elements that are going to be in group 1, or not in group 1, and all of the elements that are going to be um, that are in the main group, right? So then that's groups. Let's see, let's go back to the periodic table. So all the elements that are in the main group, so that's going to be like from 13 to 18, and then 1 and 2, right? All of these guys are going to try to obey the octet rule, meaning that they're all going to try to be like noble gases when they form ions, right? So in the case of carbon, nitrogen, oxygen, and fluorine, all of these guys are going to try to be like neon. So they're going to try to gain electrons to be like neon. And so they're going to be called isoelectronic to neon. Okay. And so this is just showing us that. So nitrogen here, it's going to have to gain 3 electrons to be like neon. So because it has 5 valence electrons, which shown by the Lewis structure here. So it needs to add 3 more electrons so that it can be just like neon. And so then to be so that it has 8 electrons around it, like neon, it needs to gain 3 electrons. And so then when it gains its 3 electrons, you're going to get N3 minus. And then that's the same thing with the oxygen. It needs to gain 2 electrons. And then once it gains its 2 electrons, it's going to be O2 minus. And fluorine needs to gain 1 electron. And then it's going to be F minus. And we know that neon is the ideal gas. It's perfect. So it's good to go. It doesn't have to gain anything. Okay. And it has 8 valence electrons around it. Now, sodium is also gonna want to try to be like neon as well, but it has to lose 1 electron. So when it loses 1 electron, it has 10 electrons around it. And so then we end up with Na plus. Magnesium loses 2 electrons, and so it becomes Mg2 plus. And aluminum has to lose 3 electrons, so it's going to be Al plus. So the metals are going to be losing electrons. The nonmetals are going to be gaining electrons. And this is just showing you what they have to do to become, or the type of ion that they form, monatomic ion that they form, to be like neon, right? So hydrogen could either be H minus or just H plus. These guys have to be N3 minus, O2 minus, F minus. Aluminum has to be Al3 plus, sodium, and then so on and so forth. And so you can kind of use this table to kind of get a gist of what you're supposed to be doing, okay? And to remind you. Okay, so we've talked about ionic bonds. We know that an ionic bond is going to be between basically going to be a metal and a non-metal in most cases. There are some exceptions where we have all non-metals, but they're separated by polyatomic ions, or they're using polyatomic ions to sit there and get that state. So ionic bonds, they're going to be a result of the attraction of opposites and positive opposites charges attracting to each other. So our positive and our negative are going to attract to each other. So nearly at all ionic compounds are going to be solids at normal temperature and pressure. And then they're going to try to form a organized crystal lattice. And I'll show you what that means later. So we know that they have to add up to 0. So they're going to be neutrally charged when they're together, when they're a compound. Now the ions independently are charged, but when they're together, they have to balance each other out. Let's see. And the way that the crystal structure basically work is it's going to be a result of those alternating charges. So that positive, that negative, that positive, that negative. So they're going to organize themselves so that positive is going to be surrounded by negatives, and then a negative is going to be surrounded by positives. And at room temperature, they're going to be, of course, solids. And then when we boil, or we get them to the boiling point where they become a liquid state, they're able to conduct electricity, right? And so they're good at electrical conduction when they're in a liquid state or when we add water to the ionic compound. This is just a reaction between sodium and chloride. So basically, we put a piece of sodium into chlorine gas, and then as a result of it, it's going to form sodium chloride, which you guys all know as salt. Okay, so in that case, what happens is that the sodium atom is going to give up its electron to the chlorine atom. And so the chlorine is going to become negative, and the sodium is going to become positive, right? So the chloride is taking the electron, and the sodium is giving it up, okay? And so as a result of that, they're going to come together based upon charges. So that plus and that minus, that plus and that minus. So this is that crystal lattice that I was talking to you guys about. So the chlorine is going to be the green sphere. The sodium is going to be the black sphere or the gray sphere. And so you'll notice that black sphere here is surrounded by chlorine, okay? And that's based upon the charge itself. So those positives, the positive of the sodium is going to be interacting with the negative of the chlorine. And so they're just going to surround it so that it's based upon those charges. So you're going to get alternating, positive, negative, positive, negative, positive, negative. And this is just showing you another view of it. So you guys can see this is happening here. This is just showing you that when you boil sodium chloride, so you heat it up high enough so that it actually boils, then it actually is able to conduct electricity. So when we boil ionic compounds, we're able to conduct electricity. Or if we put them in water and the ions are separating, then we're able to conduct electricity. So when we talk about the monoatomic ion, we know that that's just an ion formed from a single atom. So like sodium, so sodium will form an Na+. So that's just monoatomic. Polyatomic ion, we know that that's going to be an ion that's formed from multiple atoms together. And you guys have a polyatomic ion table. Okay. So we know when we're writing our monoatomic ion, we're always going to put the symbol for that element, and then we're going to put the charge that it is. So like Na, we're going to put a plus, right? And so we're going to be using the superscript following the element, okay? So if it was magnesium, it's Bag, 2 plus. So that lets me know that I have 2 electrons that have been lost. And when we name this guy would be called the sodium ion. This guy's going to be called the magnesium ion. Okay, you notice that we don't have to put anything towards that charge. Now, again, this is only going to work for the main group. It's going to be different when we're talking about transition metals, post-transition metals, lanthanoids, actinoids, and sometimes metalloids. Okay, so gotta have myself. When we're talking about negative ions, negative monatomic ions, let's say we had sulfur. Sulfur is going to be 2 minus, and so the name that we would give that would be sulfide ion. So what we do is we drop the last part of the valve. So in this case, the U and the R, we'll drop that part and we replace it with IDE. So that also lets us know that that's going to be the anion and it's going to be the end of our compound, of our ionic compound. And so we would call this guy the sulfide ion when it's written by itself. Okay, so write the names of Br minus and Ba2 plus. And then write the formulas for the potassium and the fluoride ion. Do you have any volunteers?
For Br is gonna be bromide,
Okay,
and then for Ba2 plus is gonna be barium ion.
bromide ion and the barium ion. Okay, so I have another volunteer for the formulas for potassium and fluoride ions.
For potassium, would it be just K negative?
Would it be K negative? Where's potassium located at? What type of element is potassium?
It's a metal.
The metal. So what did we say about all metals are going to end up being what charge?
Positive.
Okay. So you mean K positive? Because
Yes.
it's losing 1 electron. Okay. And fluorine, the fluoride ion.
Would it be F negative because it's a gas?
Not because if it's a gas, it's because it's a non-metal, right?
Not, yeah, not metal.
Yep. Okay. And it's only 1 away from being a noble gas, right? It wants to
Yes.
gain that 1. Okay. So we've talked about Roman numerals already. Yes, actually see the text. So when we're talking about transition metals, post-transition metals, lanthanoids, actinoids, metalloids, all of those guys are going to have to use the Roman numeral to let us know the charge because some of these metals can have multiple ions. They're not going to obey the octet rule. They're not going to want to try to have 8 around them. They're going to be different, and they have different ways of getting stable. And so if we talk about iron, we could have iron 2 plus. And so the way that we represent that charge is by writing that Roman numeral 2, to let us know the charge on the ion. If we have iron 3 plus, then we write a Roman numeral 3. Okay. And then you guys remember your Roman numerals? One would be what?
I.
It would be Roman numeral 2,
2 I's,
and then Roman numeral 3,
3 I's,
Roman numeral 4,
IV.
right, IV. Roman numeral 5,
V.
Roman numeral 6,
VI,
VI.
Roman numeral 7,
VI, I,
Roman numeral 8,
V with 3 I's.
okay, Roman numeral 9,
IX,
and Roman numeral 10.
X.
Okay. Okay, so this lets us know what charge it is. Now, that's the thing that we always have to remember, because our first instinct is to try to put how many there are. So we don't want to put how many there are. We just want to know the charge of one ion. So the charge of one of the ions. Okay. So now there's a special case, which is mercury 1. The mercury 1 ion is diatomic. So it always has to be written like this because it's diatomic. Okay. So you'll never see just Hg plus. It always has to be written as a diatomic. Okay. So that is the only diatomic ion out there. Okay. So then name these ions: Mn 2 plus and Mn 3 plus. How would I rate those out?
Would it be nickel 2 ion?
Mn? Mn is nickel?
My bad. Magnesium 2 ion.
Is it magnesium?
Yes.
Are you sure? Don't put money on it.
Yes. Manganese, my bad.
Manganese. Man, I could have got some free money. Okay, so we know it's manganese. And then you said manganese. What will be the
I.
okay? And then the other one would be
3 I's.
okay. And then so what would be the chemical formula for nickel 2 plus?
Ni 2 plus.
Okay.
And Ni 3 plus.
Okay. Questions? Okay, good. Okay, polyatomic ions. So we've talked about them. You have a table that is dedicated to them. So polyatomic ions are going to be just like any other ion, only thing they're acting as one unit together. So they're going to consist more than one atom. So for instance, we have the ammonium ion, which is NH4 plus. So that has one positive charge, and it's composed of one nitrogen and four hydrogens. They're working together. That charge is on that whole compound. Hydroxide, OH minus, right? So then it's oxygen and hydrogen, and then they're bonded together, and then they're sharing a negative charge. So altogether, they have a negative charge. Okay, so when we do ionic compounds, at the end of the day, they have to balance out, and we want to try to keep the smallest number that we can get so that they balance out. Okay. So, oops, turn away. So write the formulas for ammonium bromide and ammonium sulfide. So what is the ions for ammonium? What is the ion for ammonium? Chemical formula for ammonium ion.
N for NH4.
So it's NH4. And what charge?
-2
Are you sure?
or +2.
Are you sure?
Mm,
Where can you find out?
polyatomic.
My polyatomic ion table, right?
Mhm.
Okay. So go ahead and take a look at our polyatomic ion table.
Just a positive charge.
Just a positive charge.
Mhm.
Okay. And then bromide, what is the charge on the bromide? Um,
Just a negative charge.
It's just a negative charge. And then we'll do the sulfide. What is the charge on our sulfide?
-2.
-2. Okay. So if I'm putting bromide and ammonium together, what is that going to look like? What is going to be the chemical formula?
NH4Br.
And then what about the ammonium and the sulfide?
NH4 and then parentheses 2S.
Okay. Parentheses 2S. So I have to put the parentheses around the whole thing because I need multiples of it, right? So good job.
Why did you put the 2 on the bottom of the parentheses?
Because that lets me know how many I have, just like we do H12, right? Doesn't that let me know how many hydrogens I have?
Yeah.
Yeah, same concept. So you're using the exact same concept, but you use the parentheses now to let you know that it's the full thing. It's that entire thing that you have to put.
Okay.
Okay. Okay. So write the formulas for aluminum oxide and barium nitride. Any volunteers?
Would the first one be L1, 2, and O3?
So you're saying Al 2 and O3.
Yes.
That is correct. So since we know that aluminum has what charge associated with it?
+3 charge.
It has a +3 charge. And then oxygen has what charge?
A +2.
A +2. Is it a +2?
My bad. -2.
Okay. Okay, so we can do our cross multiplying since these guys aren't multiples of each other. So then in that case, we can end up with Al2, O3. Because at the end of the day, they have to be equal to each other. We need to get a total charge, in this case, of 6. So we'll need 2 aluminums. So then that would give me our +6. And then we need 3 oxygens. 3 times -2. And then that should add up to 0. Okay. What about the barium nitride? What is the charge on barium?
A 2+.
We know that barium is a 2+, and nitride is,
M3 negative charge.
okay. So again, we do that cross multiply. Okay, questions? No questions? Any concerns? Cash? I take Venmo. Okay, we'll move forward. Okay, so when we're naming ionic compounds, we're going to have to use the Roman numeral for those elements that, those metals that are either a metalloid, actinoid, lanthanoid, post-transition metals, or transition metals. But we don't use Greek prefixes, so no Greek prefixes. We always write the cation first, and then we write the anion. We want the positive first, and then the negative. Okay? So let's go ahead and write the name for these compounds. Okay, Rosa, you're going to get the first one for me. Anna Marie, you're going to get the second one for me. Maria, you got the third one. And Merry Christmas, you got the fourth one. Okay, so we're going to give iPhone 13 Pro a little bit of time. Anna Marie, you going to help me out?
Magnesium iodide?
Okay, good job. Okay. Maria?
Is a tri-silver?
What about those Greek prefixes? No Greek prefixes.
Silver.
Okay. Silver what?
Nitrogen.
Not nitrogen.
Not,
Nit
mm,
Remember, it's at the end of the compound, so we have to use what?
mm,
So at the end of the compound, we always want to change it to "ide." Let us know that it's the end of the compound. So it's silver nitride. Now, silver is a transition metal, but we know that silver is always going to be a +1 charge. It's an exception, so you don't have to put in the Roman numeral for this one because it's always going to be a +1. Okay, Merry Christmas. Merry Christmas. Are you there? Anybody want to help Merry Christmas out?
Would it be manganese 2 chloride?
All right. Be manganese 2 chloride. iPhone 13 Pro. Anybody want to help iPhone 13 Pro out?
Is it
Lithium bromide.
Lithium bromide. Okay. Questions? Okay. So acids. We've talked about acids. We're going to talk about it again. So when we talk about acids, we're basically going to be looking at the hydronium ion. Let me tell you what the hydronium ion is. So I told you H plus is a proton donor. So what happens when H plus is in water? It actually will bind to water, H2O, and it will make H3O plus. And that is the hydronium ion. So really, it's just that H plus ion that's just bounded to water. Now, this happens because it's kind of clingy. It wants to connect to something. And so it does that to water immediately since that's what's around it. And it just does it naturally when it's boiled into, like when certain gases are boiled into water. So for instance, hydrochloric gas, when it's boiled into H2O, you basically form the chloride ion and the hydronium ion. And so really all that is just your HCl, AQ. Okay. So these are the name of 5 acids. So the H2 added onto carbonate causes it to become carbonic acid. H added onto the nitrate cause it becomes nitric acid. Those three H's added onto phosphate causes it to become phosphoric acid, and two H's added onto sulfate causes it to become sulfuric acid, and H added onto chlorate causes it to become chloric acid. And so if you guys remember, I ate organic apples despite them being poisonous. Okay. So if you go to your polyatomic ion table, you guys will recognize this as carbonate. Okay. So then in this case, for us to form that acid, we're going to replace the 8 with ic and that acid at the end. So carbonic acid. You'll recognize this as nitrate. So then you're going to replace and then we're going to end up this with ic, and we end up with nitric acid. And then so on and so forth down the line. Does that make sense? Are you guys there? Am I talking to myself?
Yes,
Yes, I'm talking to myself, or it does make sense?
it makes sense.
Okay. Okay. Let me keep this. Okay, so in terms of these acids, so we're going to have to pay attention to the variations between the oxygens. And then, of course, the hydrogens are going to be balancing out the charges on the anion, right? Because again, with acids, it's acting as an ionic compound. And so the H plus has to balance out the charges. So for instance, we know that phosphate, PO4, has what charges associated with it? What's the charge on phosphate? Where would I find that at?
-3.
It's a -3 charge. Okay, so we need enough H pluses to balance out that phosphate. So then how many H pluses will I need?
3.
I'll need 3. So then when we write our formula, it's going to be H3, PO4, and we want to put AQ to let us know that it's an acid. So that hydrogen and that AQ lets me know that it's an acid. Okay. Now, when we make reference to oxyacids contain at least one hydrogen atom, and then it also contains oxygen, right? So that makes it an oxyantacid. So these guys are considered oxyacids because it has the hydrogen and it has the oxygens. Okay. So halogens, we know that when they form their oxy acids, we're going to name them because, again, it's chlorate, so it'll be chloric acid. Bromate, so then it'll be bromic acid. And we know that the charge has to balance that. +1 from the hydrogen has to balance the charge of my chlorate, which is what charge? The LO3 has what charge associated with it?
Negative?
It's a negative, yep. So then we only need one positive to balance it out. So we only need one H to balance it out. Okay. Okay. Given a name H2SO3, which is sulfurous acid, what is the name of H2TeO3? So this is also playing with that rule that when you're in the same group, you're going to behave very similarly. Okay. So is T and sulfur in the same group? Look. So Te and sulfur, aren't they both in the same group? Groups,
Yes.
periods. Okay. So we know that it's going to behave like sulfur. So when we name it, it's going to be named similar to how we named the sulfur, the one that had contained sulfur. So what do you think the name of this guy is going to be called?
Beryllium acid.
Would it be tellurium acid? Look what we did with the sulfur. Do we call that sulfur acid?
Tellurious acid.
Tellurious. That's right. So because it's behaving the same way, we're going to treat it the same, right? So we need to call this guy tellurious acid. Okay. Because it's under the same group, it's going to behave similarly. Okay. So if I'm given the formula of perchloric acid, what is the formula of perbromic acid?
HBRO4.
That's right. Okay. And so this is playing with those oxygens. So when we start losing those oxygens, right? So we know if we have one more oxygen than the 8, or we're going to call it perchloric, right? We have an additional oxygen. So it's greater than. If we lose an oxygen, it's OUS. If we lose 2 oxygens, it's hypo-OUS. And then if there's no oxygens, we use hydrochloric. Okay. So what is the name of H2SO3? And we're assuming that it's going to be an acid. So let's put AQ at the end. So we know that it's an acid.
Sulfurious acid.
Yep. Okay. What will be the formula of tellurious acid?
H2TeO3.
Okay. Okay. We've talked about the anions. That's going to be on your polyatomic ion tables. We know that ones that are in the same group are going to behave similarly, just like the case for the acids. And so here's our anion. So you can see how our anion relates to our acids. Okay. And so as we drop down, so this would be chlorate. So one more than chlorate would be perchlorate. One less than chlorate is chlorite. One less than the chlorite is hypochlorite. And then if there's no hydrogens, we call it chloride. Okay. What is the name of NO2 minus? NO2 minus.
Nitrate ion.
The nitrate, ATE, or nitrite?
Nitrite.
Nitrite. Yeah. Okay, what is the formula of hypoidoate ion? Hypo
IO negative.
IO negative, that is correct. So we know iodine and chlorate are in the same one. So if we had chlorate, chlorate would be ClO 3 minus. So chlorite, ClO 2 minus. And then hypochlorite would be ClO minus, right? So then since they're in the same group, 3 minus, this would be IO 2 minus 2, and minus, and then IO minus. So this would be our hypo iodite. Iodite. And iodate. Okay. Okay, so this is just showing us the oxyanion compared to the acid and how they differ from each other. And so you guys can see carbonic acid, carbonate ion, nitric acid, nitrate ion. Okay. Okay, so write the name of MgBrO42. What is that metal in front?
Magnesium,
Magnesium. And then what is this ion called?
bromate,
Is it bromate?
Would it be perbromate?
That's right. It would be perbromate. So then we name it together, putting it together. Since it's an ionic compound, we just use the anion. The anion was what? I mean
magnesium,
the cation, sorry, my bad. Magnesium. And then the anion is bromate. Okay. What about the next one? What would be the chemical formula?
K2SeO3.
Okay. K2. SeO3. We know that selenate is going to be similar to sulfate, and so selenite should be similar to sulfite. And so we know that sulfite has 3 oxygens, S and 3 oxygens. So selenite should have Se and 3 oxygens. And we know that the charge is -2. Good job. Okay, so when acids have more than one H, they're called polyiprotic. And so initially we're starting off with this acid that has 3 H's. If it loses one H, then we have to change the name. We call that guy dihydrogen phosphate ion. If it loses 2, we call it just hydrogen phosphate ion. Now, don't let this get you confused, but we've got to be sure that we're able to distinguish only under these circumstances will you be using the Greek prefixes with an ionic complex. This is the only circumstance that you do that. When it's polyiprotic, which basically means it has more than one hydrogen. Okay, and so this is an example of how they do it when it loses. So this one has 2 hydrogens. So when it loses 1, it becomes hydrogen carbonate. Its common name is bicarbonate. When sulfur loses 1, it's called hydrogen sulfide. The hydrogen sulfide ion. Okay, do you guys see how that works? Yes, no, maybe. Okay, so then what is the name of FeHCO3? What's going to be the charge on our iron?
3.
It's going to be a 3. So iron is going to be a 3 plus. So let's go ahead and write that one down. So if it's iron is 3 plus, then what would we name that ion? Iron what?
Iron 3.
Iron Roman numeral 3. Okay. And then what was this called based on that table that we just looked at?
Hydrogen carbonate.
Okay. And that's it. So just break it down. If you have the cation, just take the cation. We know that the cation is iron 3. And then the anion is hydrogen carbonate, and it goes together. It's just that simple. Just those two coming together. Right? And again, this is for ionic complexes. Just identify both of the players. Okay? Write the formula for ammonium hydrogen phosphate.
Isn't it gonna be parentheses NH4, parentheses 2, and then HPO4?
That is correct. Okay, so we know that hydrogen phosphate has a -2 charge. So we also know that ammonium has a +1 charge. So we need 2 of those to balance out that charge. That's it. Good job. Okay, so hydrates is just the addition of water. So if something is anhydrous, that means it's lacking water, or water has been removed from that compound. Okay, anhydrous means that water has been removed from that compound. Okay, and the way that we do waters right? So in this case, this guy would be an anhydrous compound. But this side here, this would be called copper, copper 2 sulfate. And then it would be penta, because we're going to use Greek prefixes when we talk about hydrates. So it'll be pentahydrate. Okay. And then on my product side, this would be called copper 2 sulfate. Anhydrous. To let us know that the water has been removed from it, and so the water is independent. When it's like this, when it's the times, that basically means that it is together, it's united. When it's the plus, that means that they're separate from each other. Okay? Questions? Okay, so how many waters are associated with this sodium, the sodium carbonate?
10.
10. So then how would I write the name? Start with the name of the compound.
Sodium carbonate.
Okay, and then,
Decahydrate.
okay, what about write the formula for nickel 2 chloride hexahydrate?
NiCl2 and then 6H2O.
NiCl2 and a big old dot, 6H2O. Okay. So there's one more set of bonds that I am going to talk about, and that's called metallic bonds. So that's when metals are coming together and interacting with each other. And so often when we have metals that are coming together, we call them alloys. Two different metals that are coming together, they're called alloys. Now, what they do is different than the other ones. You know, like in the case of ionic bond, you have one giving it up to the other one. Well, in this case, the metals, they just drop their electrons. They'll drop them, and then they'll act as if that electron is a negative charge by itself, and then there'll be a positive charge by itself. So they do what we call delocalize the electrons. So they'll interact by delocalizing electrons. So let me show you what I mean. Okay. So here, this is an electron this is an atom that has to lose one electron. So like sodium. So this would be sodium. And this would be that electron that it just drops next to itself. So it delocalizes it. So then that sodium is a plus, and then the electron by itself is acting like a minus. So it's doing this independent of anything else being around, so that it's able to act like you have plus and minus charges, plus and minus charges, plus and minus charges. Okay. And so this is the case where we have something like magnesium, where it's dropping two electrons next to itself. And so then in that case, it acts like it has a 2 plus, and then it has the two electrons that are keeping it stable, you know? And so they're interacting by charges, but by delocalization of the electrons. And so we call these guys metallic bonds, and that's only between metals. A metal and a metal, they form a metallic bond. Okay, here are famous cases where we have alloys, or we have these metallic bonds being formed between two metals. So here we have 18 karat gold, which is 75% gold, 12.5% silver, 12.5% copper. We have brass, which is 60 to 95% copper, and then it's 5 to 40% zinc. We have bronze, which is 90% copper and 10% tin. We have carbon steel, which is 99% carbon and 0.2 to 1.5%. 99% iron and 0.02 to 9.5% carbon. We have pewter, which is 91% tin, 7.5% antimony, and 1.5% copper. And stainless steel, which is 70% iron, 18 to 30% chromium, 8 to 10% nickel. Now, sometimes they have other elements that are in there for the stainless steel, but they're very low in quantity. Sterling steel, which is sterling silver, which is 92.5% silver and 7.5% copper. Okay. Okay, so those are some of the common alloys that you may come across. And so, like, how many of you guys wear jewelry? Anyone? So, how many of you guys have rose gold or have heard of rose gold?
Is it the pink colored
Yep.
gold?
Yep, it's the pink colored gold.
Yep.
That one actually has a lot more copper in it than 18 karat gold. And so that copper addition as it causes it to have a pink color to it. And so you'll end up with like 30 to 40% copper in that case, and then the rest of it will be kind of gold. Okay. Questions? Okay, so this is just a summary of ways to memorize or remember the nomenclature system. And that's all I got for you today. I'm going to let you guys go a little bit early, actually very early today. And but before I let you go, so your practice exam will be coming up tonight at 11:59 p.m. So it'll open up tonight, and you'll have up until the time that you have the exam, which is going to be due Saturday at not this Saturday, but next Saturday, the 28th at 11:59 p.m. And I will be out of town all next week. You guys are doing an altar, right? An prayer for extra credit points. Is that true?
What time did they say the setup was going to be?
You can start setting up this week. So, and you want it done before next Thursday. So, but this week would be good to bring this in and start setting up. In the lab, I have some candles and I have some other things that I'll be bringing in this weekend. So, what I'll do, I'll talk to Maribel, so she'll be able to let you in to come and get it. It'll be in a box next to the door, so you guys can get it and pick it up. But typically, I let you guys do what you guys want to do, and then the idea is that we want to do a great job because there's always a competition. And one already says they're gonna whip you guys' butt, so you don't want them to do it, right? Because you get the better you guys do, the more extra credit points you guys get. Did I tell you about the extra credit points?
Yeah.
Okay. Who's going to be responsible? I need somebody to be responsible and to work with Olivia, because she knows what the table is at. Olivia Vega. I'm not going to be around. Anybody want to take responsibility? Oscar, you seem like a responsible gentleman.
Your voice keeps cutting out from the mic.
It's because I'm sick. How about now? I need somebody who's going to be responsible for making sure that the altar gets put up. Okay, excellent. Thank you guys for volunteering. So we'll have Oscar and Jasmine and Maritza. You guys are going to be my go-to people. So you're going to be working with Olivia. Okay. And I need pictures, documentation of you guys working on the altar. So if you guys don't send me a picture of you guys working on the altar, then I don't give extra credit points for that part. So there's going to be a spot on Canvas so that you guys can upload your pictures. So make sure you guys take those pictures. Proof is in the pudding, right?
Okay, and where are we gonna set it up? It's gonna be in the
It's down.
restroom or
It's downstairs on that first floor. And then you guys, I think we have the last two tables closer to the back door or the door in the back parking lot. So, but
Okay.
ask Olivia Vega. She'll show you where it's at.
Okay, thank you.
And so you guys are 2A and 1A has a table themselves too. Okay. Any other questions?
Will we be getting 2 chances on the exam like last time?
Nope. That was one time fluke, you know. So no, it's one and done. So make sure
Okay.
you guys do the practice test.
And it's gonna be like last time, online, right?
Yep, just like
Okay.
last time. Yep. The tutors are going to be having reviews this coming week. So keep your eye out for the reviews. They're going to be online. And then I won't have access to next week. We won't have a class on Monday. You guys can come and work on the altar that Monday and get it done and get it knocked out of the way. That will probably be the best thing to do. But there will be a video up for you guys to watch for class on Wednesday. I'll be at a conference all next week. So. And sorry about today, last minute telling you guys about coming online, but I'm not feeling 100%. So um, at least we still got through the lecture. Okay. Any other questions?
Yes, for the last two labs that we did, when is gonna be the due date?
I will do those when I get back. So we'll say that they're due when I get back. So that gives you
Okay.
guys enough time to finish up the last two labs, right?
Yeah, okay, thank you.
If they say it's already due, don't worry about it. We'll fix that. Okay.
Okay.
Any other questions? Okay, then I will let you guys go. You guys have a good day.